guys, what's up? So today we're going to be looking at inequalities, guys, and it's a pretty simple topic to me. It's really easy to understand, and it says the inequality signs. We're going to be looking at inequations, right, which is basically the same thing as inequalities, and it says the inequality signs less than or equal to and greater than or equal to are used to represent inequations, right? And so this should be they, right? They mean is less than. This one means is less than, and it's usually a beak facing the right. And is less than or equal to would be just like how you see it here. And is greater than or equal to, you'd have it this way, facing the beak would be facing the left side, and is greater than or equal to the beak would be facing the left side with the equal sign underneath. Cool. So guys, it says here an inequation is a statement involving inequalities, right? So any equation that you see that involves an inequality is an inequation, right? And a linear equation with one unknown can be written in the form ax plus b is less than 0, where a and b are real numbers and x is the unknown value. Or you have ax plus b is less than or equal to 0, or ax plus b is greater than 0, or ax plus b is greater than or equal to 0. Cool? Nice. So this is pretty much just the theory around inequalities, right? And now we're going to be looking at some inequalities themselves. Okay, guys, we're going to look at some examples. All right, guys, so we're going to be looking at these examples here, right? We have two examples that we can look at. Right, we have two examples that we can look at, guys, and it says here, for example, we have 4x plus 3 is less than 7, and 3x minus 5 is greater than 4, and it says the solution of a linear equation is a range of values, and hence it is given by a solution set. So I'm going to work out these two examples and show you exactly what I mean. So let's do the first one here, right? And we're going to have 4x plus 3 is less than 7, right? So we have 4x is less than, the first thing we're going to do is we're going to put this 3 over to the right side of the equation, and it's treated just like an equal sign in that case. So we're going to end up with 7 minus 3, so the positive 3 becomes a minus 3. Then we're going to get 4x is less than 4, and then we're going to get x is less than 4 divided by 4, right? And we're going to end up with x is less than 1, right? So x is less than 1, guys, is a range of values, okay? It's actually a range of values because it would be everything less than 1. So, for example, if this was, it would be 0, -1, -2, -3, so it's a range of values, okay? So we're going to write here the solution set of this inequation is x, right? X such that x is less than 1. Cool, guys? And this is actually the solution set for the equation. This is what you see here. All right. Yeah, and that's the answer. So let's actually solve the second one here, right? Let's solve the second one here. I'm gonna use a darker blue in this case, and we're gonna have 3x is greater than 4 plus 5, because we carried this 5 to the negative 5 to the right hand side of the equation. And we're going to end up with 3x is greater than 9, and we're going to divide both sides of the equation by 3. So we're going to end up with 9 over 3. Well, we're going to divide the right side by 3. This 3 goes down here, and we end up with x is greater than 3, right? So the solution set is x such that x is greater than 3. Cool. And it's pretty simple. Pretty simple to understand, guys, and great. It's simple as ever, and we can move on. We can move on and look at some more inequalities, okay? All right, guys, so we're looking at this situation here. It says note briefly, right? And we really need to note this briefly, guys, right? And it says here, if an inequality is multiplied, right? So if an inequality is multiplied or divided by a negative number, then the sign is changed. Okay, guys, so that's really important to understand. Cool. So let's look at some examples here, right? So let's look at an example. Let's look at the first example, and it says, given that you have -4 is less than 2, and this is true, right? This is actually true. So given that um, -4 is less than or equal is less than 2, right? So it's not equal to. -4 is definitely less than 2, right? And that's true. If we multiply both sides, right? If we multiply both sides of the equation by -2, we get, so we're going to multiply that -4 by -2 and we get a +8, right? And then, of course, we have to switch the sign, right? So we have to switch the sign. So let me just put a pink there, and I'm just going to switch the other way around. The beak is going to change, and then we're going to end up with -2 times this 4 would give us -4, right? And that makes perfect sense because +8 is actually greater than -4. So this makes sense. If we had actually put 8 is less than -4 without changing the sign, this would actually be incorrect, right? So anytime you're multiplying an equality by the negative sign, then you definitely need to switch the sign. All right, guys, you need to switch the sign. So for example now, guys, let's say, for example, as well, we divide these two numbers here. Let's say we divide these two numbers by -4. So let's say we're going to divide both sides by -4. Cool. So -4 here and -4 here. If we divide both sides by -4 as well, we're going to end up with -4 divided by that 8 would actually give us -2. And then this -4 divided by -4 would give us a +1, right? And guess what, guys? We have to switch the sign again. We'd have to switch this sign over to the other side because we'd end up with +1 is greater than -2, and that makes perfect sense. But if we didn't switch the sign and we said -2 is greater than +1, this would be incorrect, right? So when we divide both sides by a negative number, we also have to change the sign as well. So anytime it's multiplied or divided by a negative number, then the sign is changed. Okay, guys? Anytime you multiply and divide by a negative number, then the sign is changed. Okay? Okay, so let's move on, guys. All right, guys. So we're going to be looking at the solution of linear inequations in one unknown. And guys, we're going to look at the same 7 cases that we looked at in the last video when we were handling just normal equations. And we're going to look at inequations containing addition, right? So let's just solve this inequation, right? We have a situation where x plus 2 is greater than or equal to 7. And let's just solve that. So we have x plus 2 is greater than or equal to 7. And we're going to carry the 2 over to the right side of the equation, and we're going to get 7 minus 2. So x is greater than or equal to 5, and that's the answer, right? But guys, we're actually going to look at the situation on a number line, and we're going to look at the situation on a graph, how to represent this. So the solution set is equal to x let me just put a bracket here, such that x is greater than or equal to 5, right? So if we represented this on a number line, guys, if we represented this on a number line, we would end up with, let's say we have 0 here, 1, 2, 3, well, no, guys, let's put 0 here. Then we have 1, 2, 3, 4, and 5 here. And we can just draw a line here through, well, we can draw a circle here at this 5. And because it's greater than or equal to, we'll have to shade this circle, right? And we would see clearly that everything would be represented as 5, which x is equal to 5. So it starts from that 5 while it's shaded, and it would go across to 6, 7, 8, and continuously to infinity because x is greater than or equal to 5. Cool? All right, so let's represent this on a graph now, right? Let's represent this on a graph, and we're going to just draw our graph neatly here. We're going to represent it by your x and y values, of course. So we're going to put a 0 here, and then we're going to put 1, 2, 3, 4, 5. So if we represented this on a graph now, right? Let me just carry this over to this side. We would draw, right? We would draw a line through. Yes, we would draw a line through the x variable, right? Because x is equal to greater than or equal to 5, and we would actually put a solid line, right? We'd put a solid line, and the region to represent x being equal to or greater than or equal to 5 would be over here. So everything over this side would represent x greater than or equal to 5. And yes, so we use a solid line. We use a solid line to represent that because we are trying to say that it includes the 5 and everything to the right side. Cool? That's how we would represent it on a graph. Okay, so that's pretty simple, guys. So let's move on to another situation here, case 2, which is looking at subtraction. Cool? That's it. And I'll see you in the next lecture. And remember to do your best, and God will do the rest.